एव्हरीवन. ऑल एक्झाम कट्टा या यूट्यूब चॅनलवरती सगळ्यांचे सहर्ष स्वागत आहेत. आपल्याला माहिती आहे सध्याच्या रिसेंट MPSC पोस्टमध्ये बऱ्याचशा पोस्ट आलेल्या आहेत. त्यापैकी असिस्टंट प्रोफेसर फिजिक्ससाठी ही एक पोस्ट आहे. तर आपण या पोस्टबद्दलचा डिटेल जो काही रेफरन्स सिलेबस आहे मागचा तो आपण पाहणार आहोत. तुम्ही चॅनलवरती नवीन असाल तर लाईक, शेअर आणि सबस्क्राईब करायला विसरू नका. Let's see in detail syllabus for the post of the Assistant Professor Physics, Maharashtra Education Services Group A, Collegiate Branch. Now steps of the examination: written exam 200 marks and interview 50 marks. तुमची जी एक्झाम होणार आहे ती रिटन एक्झाम आहे 200 मार्कासाठी आणि इंटरव्ह्यू आहे 50 मार्कासाठी. लेवल डिग्री मीडियम इंग्लिश. नेचर ऑफ पेपर इज ऑब्जेक्टिव्ह टाईप. नंबर ऑफ क्वेश्चन्स आर 100 अँड नंबर ऑफ मार्क्स 200 अँड ड्युरेशन 1 hour. तुमच्या या पोस्टसाठी 100 प्रश्न असणार आहेत, 200 मार्क असणार आहेत, म्हणजेच एका प्रश्नाला 2 मार्क्स असणार आहेत आणि मल्टिपल चॉईस क्वेश्चन्स तुमच्यासाठी असणार आहेत आणि या सगळ्यांसाठी तुम्हाला वेळ असणार आहे 1 hour. फायनल मेरिट लिस्ट विल बी प्रिपेअर्ड बाय कन्सिडरिंग द मार्क्स ऑप्टेन इन द रिटन टेस्ट अँड द इंटरव्ह्यू. यस, तुमचे जे काही शेवटची मेरिट लिस्ट लागणार आहे ती तुमच्या MCQ टेस्टमध्ये आउट ऑफ 200 किती मार्क्स पडले आणि इंटरव्ह्यूमध्ये 50 पैकी किती मार्क्स पडले या दोन्हीच्या कॉम्बिनेशनवरती तुमची फायनल मेरिट लिस्ट लागणार आहे. चला तर बघूयात मग डिटेलमध्ये सिलेबस काय आहे. First is the electronic semiconductors, discrete devices, characteristics, curves and physics of PN junction, Schottky, tunnel and MOS diodes, bipolar junction transistor, junction field effect, transistor field effect transistor, metal oxide semiconductor, field effect transistor, MOSFET, unijunction transistor and silicon control rectifier SCR, optoelectronic devices, photodiode, solar cell, LED, LCD and phototransistor, diffusion of impurities in silicon, growth of the oxide, applications of the semiconductors devices in linear and digital circuits, Zener regulated power supply, transistor, bipolar, MOSFET, GFET as amplifier, coupling of amplifier stages, DC, RC and transformer coupling, RC coupled amplifier, DC and power amplifier, feedback in amplifiers and oscillators, phase shift, Hartley Colpitts and crystal controlled clipping and clapping circuit, transistor as a switch or and NOT gates, TIL, TTL, CMOS gates, multivibrators using transistors and sweep generators using transistors, UJT and SCR, linear integrated circuits, operational amplifier and its applications, inverting and non-inverting amplifier, adder, integrator, differentiator, waveform generator, comparator and schemic trigger, Butterworth active filter, phase shifter, digital integrated circuits, NAND and NOR gates, building blocks, XOR gate, simple combinational half and full ladders, flip-flops, shift registers, counters, AD and DA converters, semiconductor memories, ROM, RAM, EEPROM, basic architecture of 8-bit microprocessor, Intel 8085. Communication electronic basic principle of amplitude, frequency and phase modulation, simple circuits for the amplitude modulation, demodulation, digital PCM modulation and demodulation, fundamentals of optical communication, microwave oscillators, reflex, klystron, magnetron and gun diode, cavity resonators, standing wave detectors. Now second one is nothing but the atomic and molecular physics. In that, atomic physics, quantum states of an electron in an atom, hydrogen atom spectrum, electron spin, Stern-Gulch experiment, spin orbit coupling, fine structure, spectroscopic terms and selection rules, hyperfine structure, exchange symmetry of wave functions, Pauli exclusion principle, periodic table, alkali type spectra, LS and JJ coupling, Hund's rules and term reversal, mechanism of the line broadening, Zeeman, Fashionback and Stark effect, inertial vacancy, X-ray and Auger transition, Compton effect, principle of resonance spectroscopy, ECR and NMR, molecular physics, covalent, ionic and van der Waals interaction, Born-Oppenheimer approximation, Hiltrell, London and molecular orbital theories of H2, rotation, vibration spectra, Raman spectra, selection rules, nuclear spin and intensity alteration, isotope effect, electronic states of diatomic molecules, Frank quantum principles, laser spontaneous and stimulated emission, optical pumping, population inversion, coherence, temporal and spatial, simple description of ammonia measure, CO and HENE lasers. Third one is nothing but condensed matter physics crystal classes and system, 2D and 3D lattices, bonding of the common crystal structure, reciprocal lattice, diffraction and structure factor, elementary ideas about point defect and dislocations, short and long range order in liquids and solids, liquid crystals, quasi-crystals and glasses, lattice vibrations, phonons, specific heat of solids, free electron theory, Fermistatics, heat capacity, and Pauli paramagnetic susceptibility. Electron motion in periodic potential energy bands in metals, insulators, and semiconductors. Tight binding approximations, impurity level in doped semiconductors. Dielectrics polarization mechanism, Calcius Morse equations, piezo, pyro, and ferroelectricity. Dia and paramagnetism, exchange interactions, magnetic order, Ferro, antiferro, and ferromagnetism. Superconductivity basic phenomenology. Minster's effect. Type first and second superconductors. BCS pairing mechanisms. High TC materials. Nuclear and particle physics. In that, basic nuclear properties, size, shape, charge, distribution, spin, and parity. Binding empirical mass formula, liquid drop model, nuclear stability and radioactive decay, nature of nuclear force, elements of deuteron problem and low energy, N scattering, charge independence plus charge symmetry of nuclear forces, evidence of nuclear shell structure, single particle shell model, its validity and limitations, interactions of charged particles and X-rays with matter, basic principle of the particle detectors, ionization chamber, proportional counter and GM counter, solid state detectors, scintillations and semiconductor details, radioactive decays, alpha, beta, gamma decays, their classification and characteristics, basic theoretical understanding, nuclear reactions, Q values and kinematics of nuclear cross sections, its energy and angular dependence, elementary ideas of reaction mechanism, elementary ideas of fission and fusion, particle physics classification of fundamental forces and elementary particles, isopine, strangeness, Gelman, Nishijima formula, quark model per SU 3 symmetry, CTP invariances in different interactions, weak interactions, parity, non-conservations, K-meson complex and time reversal invariance, elementary ideas of George theory of strong and weak interactions. This is all about the physics syllabus for the assistant professor post. So if like this information, please like, share, subscribe. Thank you so much.